In this project, you'll create a 4-note piano where each button press also corresponds to an LED lighting up as a tone plays. To do that, you'll first need to use the pin mode function 9 times to set up every component you'll use. Ports 2, 6, 9, and 12 will be set as input pull-ups, and that's where the buttons will be plugged in on MakerBoard. You're also going to use one RGB or red-green-blue LED with the shorter legs plugged into A1, A2, and A3. And finally, you'll need a single color LED plugged into port A4. All of those LED pins are going to be set as outputs. Last, you'll use a pin mode function for port A5 and set that as an output. That's your speaker. You can see that I have left some blank lines in this program. The computer doesn't actually need those blank lines, and it won't do anything when the program runs, but it helps me stay organized as I'm creating all of these pin mode functions and know that the first set is for buttons, the second set of pin modes is for the LEDs, and the final pin mode is for the speaker. This is something that you can do, especially as your code gets longer, to help you stay organized. In the void loop function of this program, we have a string of if and else if statements. If you haven't done the plain 4-note piano without any LEDs, you might want to take a look at that if this seems overwhelming. The first if statement is going to check a condition between its parentheses. It's saying, is the digital read of port 2 equal to low? Because port 2 is set as an input pull-up and has a button on it, a low reading means that button 2 is pressed. If that condition is true, the if statement is going to run the code between the curly braces here. That's two functions. First, a tone function that has the arguments A5 and 500. So a tone of 500 Hz is going to play on the speaker plugged into port A5. The second function is a digital write, and it's going to turn on port A1. Port A1 has one of the RGB LED's legs plugged in, so one of those colors is going to turn on. Because there's no delay between these two functions, as soon as you press button 2, the tone will start playing and the LED will come on at what looks like exactly the same time. If the condition of the if statement is not true, then the code is going to skip the curly braces of the if statement. And next, it's going to check the condition of the first else if statement. The condition here is the digital read of port 6 equal to low? And remember, when we're checking if two things are equal, we use two equal signs. So, if button 6 is pressed, then play a tone of 700 Hz on port A5 and digital write port A2 high, turning on another color of the RGB LED. If the condition in this first else if statement is not true, then the code between these curly braces is skipped, and the code is going to check the condition of port 9 and see if that port is set to low. If button 9 is pressed, then the code between the curly braces will run and a tone of 900 Hz will play on port A5. At the same time, you'll digital write A3 high, turning on a third color of the RGB LED. If that second else if condition is not true, then the code between those curly braces is skipped and the third else if statement is checked. If the digital read of port 12 is low, meaning that button is pressed, then a tone of 1100 Hz will play on port A5 and A4 will be high, so the single color LED will turn on. If none of the conditions are true, the if or any of the three else if conditions, then all of the code in those curly braces is going to be skipped and the else statements will run. The else statement doesn't have to satisfy any conditions for its actions to run, but in order for the else statement to run, the void loop has to have checked all of the other conditions above it and found that they're false. Inside the else statement, we have the no tone function that stops playing any tones that are on A5, and we have 4 digital write low functions that turn off any LEDs that are on. So essentially, if the code reaches this else statement, it's going to shut down the piano and wait for a button press before turning on an LED and playing a tone. One thing you might notice is that if you hold down keys on the piano, you'll be able to light more than one LED color at a time. That's because if you hold down, for example, button 6, then the if-else-if statements are going to run through and find that this condition is true. So a tone of 700 Hertz is going to play, and the color of the LED plugged into A2 is going to show. If you keep holding down button 6 and also press button 2, then the next time the void loop runs, it's going to find that this condition in the if statement is true. It's going to start playing a tone of 500 Hertz, and it's going to digital write port A1 high. Because you've held down button 6 and then pressed button 2, the LED plugged into port A2 has never been turned off. Because remember, the else statement doesn't run when one of the conditions in the if-else-if statements are true. So you can hold down button 6, A2 will turn on, then also hold down button 2 at the same time, A1 will turn on, and until you release all of the keys, the else statement is not going to run. And the else statement is where we turn off the tone and turn off all the LED lights. So it is possible for you to turn on all three colors of the RGB LED and the single color LED at one time with this 4-note piano with LEDs.